Uh, so we will straight away we will go to the we'll start the program. I invite Dr. Rojit to introduce the speaker and start the program. Over to Dr. Rojit.
Yeah, good evening to all. So today we have a very interesting topic, that is biostatics in clinical research. So we all know RSSD is a organization whose main intention is to enrich our members and promote research in diabetes. So without including research topics also in our diabetes courses. And for this, we have the best person to talk on biostatics. Sir is from Chennai, Dr. Sriram Ramachandran. Sir has graduated from Madras University in Statistics, and Madurai Kamaraj University. He has done his biostatics PG diploma, and is a statistical consultant for various organizations in the IT field and in healthcare field. And he is also a member of American College of Statistics and also Royal College of Statistics. And his main passion lies in getting insight and identifying hidden patterns from data. So the data analysis, all of us, we have it's a gray area for us, and we usually depends on statistician. So you would like to enlighten on it, so that whenever we read an article or whenever we want to publish an article, so this will definitely help us. So he's going to give an overview on that. Over to Sriram Ramachandran sir.
Thank you. First of all, I thank Dr. Suresh Kumar for inviting me for this webinar, and also Dr. Rogit for my introduction. And good evening to one and all. So I will start the presentation. So I will, because statistics is people perceive as a very tough and it involves mathematics and all. So I guarantee that no mathematics is here, and I try to cover the applied part of it and why statistics, to emphasize more on why statistics, the role actually. So I try to put as interesting as possible. Hope this will be an enlightenment for you. Anyway, you are the best judge and give the feedback. Are you able to see my presentation?
Yeah.
Oh,
Yes, sir, we can see. I can put it in slideshow, sir.
Pardon?
Slideshow, yeah.
Okay. 1 minute, I'll put the slideshow.
Yeah.
Okay, now?
Yeah, sir, visible and audible.
Okay, so I'm Sriram Ramachandran, a statistical consultant. I'm also a fellow of Royal Statistical Society, London, and member of International Association for Statistical Education. 1 minute. Sorry. Slide is 1 minute. If I put it in a slideshow, screen is
No problem. You can forward
okay.
it one by one.
Okay. I'm also a member of Statistical Society of Australia and member for Association for Computer Machinery, ACM. And I can be reached in this email and mobile. So these are a few clients of me. TTK Healthcare, MBA Hospital for Diabetes, Sankara Eye Hospital, St. Isabel Hospital, Radhatri Netralaya Eye Hospital. I'm also consulting, and in all the three hospitals, I'm also ethics committee member. And I consulted for a lot of organization. And I, as a visiting faculty, I'm doing a lot of biostatistics, teaching biostatistics, epidemiology, research methods and all, data and Python, a lot of softwares also. I'm a visiting faculty in People UNI Trust, London, Banyan, a lot of VIT, Madras University, Laila Business School and all kind of things. And these are all the things I am doing. Statistical method, IBM SPSS, AMAS, Lizrel. These are statistical software and a lot of things. And I also once in Kerala, I did a 2 days workshop for in SCMS College, Kochi, actually. Hope you know that in Kochi.
Yeah.
Okay, this is a brief about things. So to start my presentation, usually I tell all of the audience, tell me this, I forget, teach me and I remember, involve me and learn. And very specially, this statistics, see, unless you dirty your hands, you cannot learn. That is a lesson I learned. And also I am communicating this lesson to everybody. Just by reading the book or just by going through some lectures, attending some webinars, you cannot fully appreciate and involve in statistical analysis. So we have to do some projects or involvement, but again, it is the interest of the domain people like doctors and clinical experts and all. It is the interest of that. But most of the inventions in biostatistics is done by biologists, applied statisticians only, not the pure statisticians. So the agenda, usually I cover why biostatistics and what is biostatistics, biostatistics in clinical research, and Q&A. If you have a question and answer. At the end of the session, I can do a question and answer. Okay. Now, in healthcare, the biggest question everybody minds in healthcare is how to elevate the health-related human suffering. That is the ultimate goal everybody is working on, that to eradicate human suffering due to disease and health-related issues. This is a very crucial question, actually. That is why we are doing a lot of research and etc. actually. And we try to understand what causes this disease, and we try to reduce the disease burden like that, actually. So, and a lot of causes are yet to unknown. That we need future invention may uncover that causes, actually. So, but why this? There's a variation in diseases, and we are not completely eradicated because of a lot of variation in measurement, therapies, drugs, procedures, processes, biomarkers, protocols, medical devices, and in human or non-human population, a lot of variation in the population, and causes error in diagnostics as well as health-related outcomes. Actually. So, but how to understand this variation pattern, both in inputs, we call inputs, measurement, diagnostic devices, these are all the inputs, actually, which is in our control. Inputs are which in our control. And outputs, health-related disease, mainly diseases, actually. Outputs are diseases or non-health related or waiting time in an hospital. Waiting time is a very painful for all the patients. Or patient's care is also very care of the patient as well as to pain of the patients or most of the outcomes, actually. How to understand that variation pattern and take necessary action to reduce this variation as well as preventive action to completely eliminate by making innovation. So setting this context, statistics only helps you. It is not the solution for all these things. It helps you based on the lot of pattern recognition, hypothesis testing, estimation, modeling, statistical, understand the hidden variation and covariation pattern, and to test the clinical hypothesis. learning decisions and predictions from this understanding, applying the statistical methods, and from this understanding knowledge will lead to continuous improvement of health-related outcomes actually. But only thing I again stress that statistics only helps you, but usually this is a collaboration of three entity. One is biostatistician and the clinical people, domain experts like doctors, surgeons, domain experts, and the computer system people. Computer now everything is computer software. So it all should go together to get the success of this thing. So everything is now automated. Now you have heard of machine learning, artificial intelligence. So many things are coming now. So these are all related to computers actually. So parallelly, all the three should collaborate. If the collaboration is lacking, the final outcome will be of not the high standard. So that is why I want to stress, always don't, statistician is only one collaborator, not, he will not solve all the problem of the health, or there is no solution in his hand to solve the problem of health. So it's a collaborator. Actual problem has to be, has to be brought by the domain expert. And statistics will help you to, for the solution, will only help with, in collaboration with the computer science, actually, with help, actually. That is a very key message you want to take. But people will think that statistician will solve all the problems. It is not true, actually, with my experience. So the objective of clinical research is to understand the health-related outcome, causal patterns, and or improve the well-being at minimum cost. That is also very important. So if you give the solution and if nobody able to afford that drug, then no point in giving that solution. At the minimum cost and suffering here means side effects or like that actually. So minimum side effects or no side effect, as well as prevent health-related problems and reduce the disease burden. This is most of the clinical research is heading towards this objective. You all agree on this?
Yeah.
Okay.
Yes, sir.
Okay. Now we will see what is a research. Because anything is like missing is not research. Research is a systematic and inquiry that uses disciplined and scientific method to answer questions and solve problems. The goal of research is to gain knowledge that is previously unknown. That is very important. You have to make that, you have to ensure that your finding is new, it's not previously done, or you have to enhance your previous findings, actually. So that would be useful for the society. And research is a cause probing activity. If you don't probe any cause in research, that is not considered as a research. Research is a cause and effect exercise. And research design spells out the strategies to answer research question and test research hypothesis. And one thing you have to know, cause should always precede effect in time. So if you collect something for a disease or something, the cause for the disease should happen before the disease. That is very, very important. If you're not able to distinguish that in your data, then for evidence for your research finding is poor. That's all. That's called, in research thing, they call cross-section. There are different types of research. The evidence is very high in meta-analysis. This is called meta-analysis. So meta-analysis means research on research. So many people have done the research on some topic. So you have to collect that information and find some information on that. That is the highest form of evidence in research, meta-analysis. Next is the RCT, in usually called experimental research. In clinical language, it is called RCTC. RCT, randomized clinical trial. That is the next form of evidence, highest evidence. Next comes cohort study and case control study. And then next is the cross-sectional research. Then the very lowest form is the qualitative research, case analysis. Case analysis is the very lowest form of evidence. So in the hierarchy of evidence, the lowest is the case analysis. Next is the cross-sectional. So in cross-sectional research, one problem is we are not very sure that effect happens before cause. So sorry, cause happens before effect. We are not able to distinguish. That is the one problem, because we are collecting data at the same point of time. We don't know whether that cause happens before effect actually. The onset of diabetics, for example, onset of diabetics is the effect actually, but he's having the cholesterol, maybe due to cholesterol or some other factor. But is that some other factor happens before the onset? You have to be very sure. If you are not very sure about that, then it is called cross-sectional research, and the evidence for that research is very low kind of. Next is a case control, and case control is more of a retrospective research. We start from the effect and go to try to find out the search for the cause actually. But here this one better thing is we are very sure that effect happens after the cause actually. And then is cohort study is more of a, we start from the cause and then end with the effect actually. It takes a long time. For example, whether smoking causes lung cancer. So we take some people and follow up and observe that whether they smoke or that. So we are very sure that smoking happened before the onset of lung cancer. That is our cohort study. So here also evidence, we are very sure that cause is happening before effect actually. This is next highest form of evidence, but these are all called non-experimental research or observational research. And research terminology, it is called non-experimental or observational research. The main difference between experimental and non-experimental research is non-experimental research, we are not manipulating the cause. But in experimental research, we will manipulate the cause and then try to find the effect. Next is the experimental research. In experimental research, RCT is the randomized clinical trials. Actually, most of the drugs and all therapies, drugs, yoga, lot of training. You have to do an experimental research. There are a lot of designs on there. I'm not getting too deep into that. Next is the meta-analysis, highest form of evidence. Okay. So, 1 minute. To describe or why biostatistics? So biostatistics will help you to describe the outcome or to illuminate the underlying causes of outcome, to find supporting evidence for causes of outcome. The strength of evidence depends on, I told you the strength of evidence is highest form in meta-analysis. So the strength of evidence depends on the research design, sampling design, and statistical analysis actually. And research design is the strategy and plan to conduct the research. Sampling design is a strategy and plan to select samples from the population. And statistical analysis is to understand the outcome pattern, test the causal pattern, and quantify the uncertainty. So this is the last thing is very, very important. There are a lot of uncertainty. So for example, you are doing a research and you are only selecting the population size is some 10,000 or assume that it's 20,000, but you are taking only 200 samples and do the research. Will they holds good for, will the evidence of the research holds good for the population? What is uncertainty involved? We try to quantify how much you are confident on that. So statistics help you to quantify that uncertainty. That is called in statistical language, you have heard about confidence level. So confidence level is nothing but quantifying the uncertainty between sample and population. So confidence. So if you have to choose the confidence level, 95% or 90% or 99%. Lot of confidence level, and power is another thing. So these are all the statistical thing. Statistical helps you to quantify the uncertainty. So that is very, very. So without statistics, we cannot quantify the uncertainty. So if you don't use statistics, we are not very sure that whether the results from the samples will holds good for population. Can I generalize to the population? Is my research is reproducible? Can I generalize my research to the population? These questions are unanswered. If you don't quantify the uncertainty due to sampling. Okay. Now the question is how to know the outcome pattern, how to know the causal patterns, how many samples I want to take from the population required, how to quantify the uncertainty in diagnosis and prediction. So these questions are answered by biostatistics. So the statistics will help you to answer these questions actually. Okay. Now statistical thinking and statistical reasoning plays a crucial role to answer the above questions. Then what is statistics? So statistics, what I define is the study of variation and covariation, the art and science of learning from data, quantifying uncertainty. Okay. And if there is no variation and uncertainty in your research, then there is no need for statistics. If all the patients have the same values, for example, we take the cholesterol value or HbA1c, all the patients are no variations in the HbA1c, there is no need for statistics. So statistics is study of variation and covariation. Covariation means the variation of between cause and effect. Actually. The association between cause and effect. Actually. So that is very, very important. Actually. Up to then, you have any questions?
So we'll have the question answer session at the end of the.
Okay. Okay.
So those who have any doubts, they will put it in the chat box. Okay, I don't have a chat box. You can ask. I will convey. You can interpret me, not a problem. Okay. Sir. I can stop and up to this. If you have any questions, you can ask me, or you can keep it.
The talk. You can proceed and finish the talk, and then we'll take up the question.
Okay. Okay. Thank you. Thank you. Now, these are all some quotations. Very known people, H.G. Wells. H.G. Wells is a very scientific fiction writer. He says that statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. And statistics is the grammar of science. Carl Pearson is a very famous person. He's a biologist and biometrician. He did a breakthrough invention in statistics called Pearson. You have heard about Pearson correlation coefficient, was invented by Carl Pearson, and also the chi-square. All the chi-square analysis, everything is invented by that is called breakthrough invention in applied statistics. Okay. Now this is a thing you should not do in statistics. People commonly use statistics like a drunken man use a lamppost more for support rather than for illumination. This is the thing I keep on telling the people, you should not just use statistics for any support or something. You have to get some insights out of your research by using statistics. To make use of statistics, for the sake of using statistics, you don't use statistics. That is my general thing. I may be right or wrong. Yeah. And he is also a very famous biologist, Sir Ronald Elmer Fisher. He only invented this analysis of variance and design of experiments and so many things he invented. He is from UK. So this also will happen in research. Calling the statistician after the experiment is done, maybe no more than asking him to perform a postmortem. You may be able to say whether that experiment died out. Actually, what he means that you have to involve a statistician before data collection. Once you are very clear about what the problem or you want to solve or what the research question you want to answer, from that itself, that's why it says it's a collaborative approach actually. From that time itself, if you involve I'm telling not a experienced statistician who has got a lot of experience in research actually. So if you involve statistician, so your research will be smooth and you can avoid a lot of rework and a lot of questions from if you submit to the journal, or then you can avoid a lot of questions or a lot of rework from the journal actually. That is then Roger Brinner is also famous by the plural of anecdote is not data. So you should not, some people will say, I have data, you do something for this. That is not correct actually. So even though you have a data, you should have a very clear research objective, what you want to get from the data. You have to be very clear. So, but that part is very toughest part actually. Actually, statistical analysis is only the whole process in research process. Only 10% is the statistical analysis, like creating table, graphs and all. But the toughest part is defining the correct research question, defining the correct research problem, and then collecting the relevant data. That is very, very important. So if you involve that statistics and how many samples I want to collect, sample size, that is also very important. So all the three, if you involve statistics at the beginning, before data collection, when you conceive your research questions and something, then the research process will be smooth for you. And John Tukey is also a very famous statistician. He invented only exploratory data analysis, and one important box plot is very important visualization in biostatistics. That technique he invented actually. So that is why what I told you, the combination of some data and edge desire for an answer does not ensure that a reasonable answer can be extracted from given body of the data. So you have to be very clear what question I want to answer from my data, what insights I want to get it from my data. Is my study is exploratory or confirm? There are two types of study. Exploratory means I don't have any question or something. I want to explore the data and get some insights of them for this problem. Or confirmatory means already somebody has done some research on that. I want to do it in a different population, or I want to add some more cost variables or risk factors or something like that. That is more of a confirmatory. So confirmatory is more of a risk. You have to test the research hypothesis and confirm. Exploratory, there is no hypothesis, only a research question. So you try to get some insights for answering these questions, actually, research problem. So these are on the lighter side. Facts are stubborn, but statistics are more flexible. This is also, people will do that. So we cannot bend the statistics for giving a. So statistics is what the data tells is that's all. You should not tweak the data to get what I want. You cannot tweak the data. That also possible, but that will not ethically correct. And figures don't lie, but liars figure. This is like if you bend the figures and make sure that people believe that it is like that, that is also ethically not correct. And this is a very, very fun side of that, lighter side. There are three kinds of lies, damned lies, and people think statistics are all more than damned lies. That is not at all also true. Definitely, if you collect the good, correct data, definitely you'll get some insights out of the data. Okay, now, why statistics? So you can read that these are weight reduction recorded after 6 months for two groups. It's an experimental study. Two groups, each with 10 people after following two different type of exercises, group A and group. Which exercise type is effective and why? Just look at the data and tell you which is effective and why. I give few minutes. Look at the data. One at a time, tell you What is your thinking on that?
A, group A.
You say group A is effective, right?
Almost equal, I think.
Why? You have to tell why. Why group A is better than group B?
The numbers add up actually to more than what is in group B.
If you add the numbers,
Yeah, it will be more in group A than group B, I think.
no.
No? Almost equal, maybe. Maybe they are equal.
Actually, numbers are equal.
Equal,
If
yeah.
you look
they
at
are
the
equal.
numbers,
Yeah,
the
they
total
are
is equal, right?
Yeah,
The
yeah.
total,
So they both are equal.
and we think that both are equal.
Yeah.
But even though if you look at it, the average of group A is also equal to average of group B.
But more,
But-
more, yeah, on the
but-
higher
But group A is more consistent than group B.
group B. Yeah, exactly. That's right.
So the variation is high in group B.
Yeah.
So even though the average is equal, we cannot conclude that there's no difference between group A and
Yeah.
group B. You have to test statistically. So statistics help you because just looking at the figures, usually people will take average and conclude that both are. So here, statistics will help you. How it helps here to know the difference? How statistics help you to know the difference? Because it considers the variation. Variation is the key here. So it considers the variation of group A and group B, and then based on the variation, even though the average is same, the group B has got higher variation. Group A is better, even though the average is same. That conclusion you can get, if you analyze this statistically, you can get that conclusion. But you have to analyze that statistically and get that conclusion. So that is very important. What is the key here is, the key message here is, you have to appreciate the variation in the data. You have to analyze the variation in the data. You have to analyze the pattern in the variation. You have to know the pattern in the variation. That is very, very key here. So that is why I put this. And this is called an experimental study. Here the outcome is the weight reduction, and the cause is the different type of therapy. Group A has got one type of therapy for weight reduction, and group B is the another type of therapy for the weight reduction. So the type of therapy is the cause, and the reduction in weight is the outcome here. So there is a relationship between cause and effect. So that's why it should be in every research, there should be a cause factor, and at the minimum, cause and effect should be present to study the covariation pattern. Otherwise, it is a very simple descriptive research, descriptive analysis, and it will not answer your research question or hypothesis. If you have a research question or research hypothesis, you cannot answer that question by simply doing some descriptive analysis. Okay. Now, I put that visually, the data visually. This will see that this is called box plot. Actually, we'll see what is. Now you're very clearly see the variation. Are you able to see the variation?
Yeah.
Because if you look that average is more or less clear, more or less same. But if you look at the variation, for group B, the variation is very high. So statistics help you to understand visually also the variation. Actually, so we'll come to that. What are the things involved in statistics? So variation is one form of human variation. So if you want to analyze that, human is also there is a variation. So that is why the message is, if there were no variation and if every observation were predictable, the mere repetition of what has gone before, there would be no need for statistics. That you have to means that every measurement is the same value. Sorry, for example, every patient has got the same HbA1c. There is no need for statistics to analyze. Or very little variation, there is no need for statistics to analyze. So, and this variation causes the uncertainty. So variation between therapies or variation between processes, variation between medical devices used, and so laboratory equipment, so many variations. There are different types of variation. This variation causes the uncertainty. So that is why it is very difficult to generalize to the population. We try to quantify that uncertainty using statistics. Okay. Now, what causes the variation in research clinic? One is due to measurement. What is due to measurement? Anybody? How measurement causes variation?
Different types of measurements, probably using different apparatus.
In a laboratory, if the calibration is not done or people not trained properly or people in different shift laboratory to, because that causes the variation. Measurement causes, so this variation is measured by, in statistics, called reliability and validity. Actually, I'm not getting into that. So every measuring instrument you are using is, you have to ensure that it is reliable and valid. Means that the variation due to measurement is in control. Otherwise, your research, I can ask a question whether your measurement, your measuring instrument is reliable or valid. How will you ensure that? If I ask the question, you have to answer. So that is why it's very important. You have to quantify the variation due to measurement, or in other words, you have to quantify the uncertainty created due to measurement. That is quantified by reliability and validity. In diagnostics also, diagnostics is also a type of measurement. And for example, sensitivity and specificity is the quantification of validity for the diagnostic instrument, actually. So it should be you have high sensitivity and specificity. I'm not getting into that. So whatever instruments you are using, diagnostics or for measuring the biochemical parameters or measuring the anthropometric parameters or whatever parameters you are measuring or using in your research, that instruments has to be, you have to ensure that that instrument has to be calibrated, and it is, you have to already people have established that it is reliable or valid. There was some study to establish that there are different methods of reliability and validity in here. They have to apply the correct method and quantify the reliability and validity. Usually reliability and validity ranges from 0 to 1. 1 is 100% reliable, but you cannot ensure that we cannot get that 100% reliable, because definitely there should be a variation between measurements, between laboratories, or between people who are using the instrument, or between the instrument itself. There is a slight variation will be there. So if you get 90% reliability and 90% validity, sometimes 80%, if it's a very complex instrument or something like that, above 80 is the idea. You have to get that thing. So here only the statistics helps you to do that actually. Without statistics, you cannot quantify the variation due to measurement, variation due to uncertainty on the measurement. So that is one area statistics will help you. But not only and other things are variation caused by other factors and time. So what do you think about this? Due to other factors and time.
Maybe variation in different time when you're making the measurements at different times of time of the day.
No, that is measurement is okay. Measurement I'm not getting. I finished. Next is due to other. For example, I'll tell you. For example, between diabetics and non-diabetics, there's a difference in variation in HbA1c. Do you agree?
Yeah.
Because that's why the variation in HbA1c causes the diabetics, correct?
Yeah.
So that is called one risk. Here factors may be risk factor also. We call it in a different name, risk factor or cause factor or confounding factor. So many factors are different types of factors are there. But very very crucial is the risk factor. What is the risk factor? So the outcome here, the variation in the outcome only I am telling. These are variation in the outcome. Outcome is disease or survival or whatever, time to event or is an outcome. So in that outcome, what causes the variation is only is measurement and due to other risk factors. And here statistics helps to quantify what is the impact of risk factors on the outcome. I want to study the impact of risk factors on the outcome. So statistics will help you to quantify that impact and also quantify that uncertainty in that impact. So next is due to inherent factors. What is due to inherent factors? Variation in the outcome.
Maybe inherent to the method of measurement.
No, other than that, this is called uncontrollable variation. Even though if you know all the factors, and for example, know that actually I invented a lot of drugs to fix all the risk factors. Completely, I fixed all the variation due to. Still, there will be variation due to unknown factors. Slight variation in the HbA1c due to unknown factors. That variation also that is called inherent. That variation also we can quantify by using statistics. And fourth one is the due to sampling. What is due to sampling?
So if we are not taking the adequate sampling, different age groups or something like that.
Yes, I told you in the beginning, no, if you have a population of 10,000, but you are using only 200 samples. But in 10,000, between 200 and 10,000, there will be variation, right? Yeah. If you take the HbA1c average for 10,000 people and take HbA1c average for 200 people, definitely there should be variation, right? Okay. If sample is not the correct representation of the population, or if your sample size is very less, then this variation will be high. So you have to ensure that the variation between sample and the population you want to generalize is minimum. Minimum. That you have to ensure. Yeah. That is why statistics help you to ensure that, actually. To ensure that, or based on that variation, it tries to quantify that uncertainty, actually. Yes. Okay, now I told you these are all the uncertainties caused by variation. Factors I told you, no, there will be biological factors, environmental factors, methodological factors, and this is called inherent variation. Chance and unknown factors. For example, difference in birth weight of identical twins. Can you explain that variation is very difficult, right? Yeah. And varying results from repeated samples of blood, urine, and tissue. There will be slight variation. If you repeat this sample or taken or do this today, and after 1 month you do the same blood test, there will be variation. The slight variation will be there. It's very difficult to explain what causes that variation. This is called variation due to chance or inherent factors or unknown factors. So a lot of things are there, but you have to be very sure on that what causes that variation. So now, what is statistics? How statistics help you for the research? So the main purpose of statistics is getting insights from the data, detecting patterns in data, detecting and controlling variation, detecting covariation, and quantifying uncertainty. Definitely, if you in your research, if you don't get any on, if you don't have any one of these, definitely fifth should be compulsory, And between the four, if you don't have any one of that, then you don't need statistics and you are not using the statistics. So statistics will help you to get insights from the data. And how to do that is a lot of methods are there. I'm not getting into that. Detecting and controlling variation. So if there is a variation between, suppose if there is a variation between variation in HbA1c between diabetics and non-diabetics, how to control that variation? So to control variation, you have to invent some drugs or methods to therapies or something that, and ensure that and do an experimental research and to see that that variation is controlled. Actually. So, for example, all drug invention is controlling variation. Suppose I invent a new drug for obesity or whatever. See, so I select a control group with placebo and other group with the what I drug invented and see that is there any difference in that. If there is a huge difference, then this variation is controlled actually. So that is why the controlling variation is means controlling the variation due to the cost factor, and you have to invent some methods to control that cost factor and to use statistics experiments to see that whether really my action has got an effect on that, on the cost factor. And these are all some pitfalls of statistics. Because of time, because 1 hour is very lesser time. Anyway, try to make it faster. So usually research people should not do this, making conclusions about a large population from a small sample. So for everything, you should derive sample size. So it tells you that sample size is very important. And sometimes you don't get samples or you only have, so you should not generalize to a bigger population. And making conclusions from biased samples and attaching importance to rare observations from large samples. Suppose you get a lot of samples, one observation is extreme, we call outlier or extreme value. You should not give more importance to that, whether you have to eliminate that or tell the reason for why I am including that value in my research. And using poor data collection methods and assuming a causal link based on observation. This is very important. Suppose cohort study. Cohort study is not an experimental study. In experimental study only, you have to say very clearly say this causes this. In non-experimental study, even though you are analyzing a risk factor or cost factor, you should not say that. For example, if you do a cohort study, by you feel that smoking is one of the risk factor for lung cancer. Even though you do some statistical analysis, do a cohort study and see that there is a significant impact, statistically significant impact of number of cigarettes smoked on the lung cancer, you should not conclude in your study that smoking causes the cancer. That is not correct. So what you have to do, this insight, you have to test it further with the experiment or clinical trials or experimental study actually. So you have to take some people without smoking and people with smoking. It's very difficult to do. In some cases, it's very difficult to do an experimental study. In the experimental study is manipulating. The difference between experimental study and non-experimental study is in non-experimental study, you are not manipulating the cause. In experimental study, you are manipulating the cause. That is a major difference between experimental and non-experimental study. So, and next, that is very important. So in observational study or qualitative study or case analysis, you should not attack, even though there is an association or relationship between a risk factor and an outcome, you should not say that this causes that. So maybe you can say there is a likelihood of risk is that, but it has to be further confirmed by RCT or experimental study actually. And making generalization about individuals from observations about group. Sometimes you study only groups aggregate at groups, but you should. The simple example is you take people from villages. Village is your sampling unit, and you do study, and you should not. And then the conclusion from the study is only applicable to the village, not to the individuals in the village. That you have to be very. People will. So I taken the village, but I cannot say that this is applicable to the individuals in the village. That's one example I'm giving. Community study like that. And unconscious bias, then attaching practical importance to statistically significant. This is also very, very important. If you get people think that if I get a statistically significant p-value is less than 0.05 or p-value is less than 0.01, you should not jump and say that, okay, I have success in my correctly identify. You should not. Maybe clinically it is not, the effect size is very minimum. Clinically also you have to see the effect. So you have to be, so statistically significant does not ensure that it is also clinically significant. Other way also, sometimes you have clinically, very clearly it is clinically significant, but you may not get statistically significant. Why? Because of lesser sample size. If you have a lesser samples, you have suppose I have only 5 samples. I have to do some genetic study, and very clearly this gene has got an impact. Only I have 5 samples because the test is very costly. For each test, I have to spend 1 lakh or something like that. So, but even though it is clinically significant, you may not get statistical significance because of the lower sample. That is also very important. You have to give your conclusions. You have to put it in limitations of the study, all these things. Actually. And statistics, these are all the very important. You have to very clearly define the population and sampling design, measurement, and descriptive statistics more of aggregation and charts, and then inferential statistics more of hypothesis testing and estimation. And another thing is statistical model is explained. A lot of things are there, but at the minimum you should have up to 5. So if any study, you have to clearly define the population and clearly define the sample and clearly define the measurement, and some descriptive statistics you have to do at least. And inferential is more of a, at least minimum 5 you should do actually. But if you do hypothesis testing and all study, 6 is very, very important. This inferential statistics only will tell you that it quantifies the uncertainty. And 7 is more of a prediction and the assessing the impact of the risk factor, calculating the magnitude of the impact of the risk factor and all comes under statistical model. There's a more of an advanced thing. So measurement, I'm not getting into that. Measuring instrument, a lot of physical instrument is there, human judgment, questionnaire, counting and all. So I'm not getting it because of the time, I'm not getting into that. And there are measurement scales or the qualitative variable. And so if we have one more session, we can get deep into that. And there are a lot of graphical techniques and also the lot of descriptive statistics. Depends upon what data you collect. And this is an example of descriptive statistics. So living place is one of the cost factor. So, but you don't have outcome here. Living place is rural, how much, and just you do some descriptive statistics on, you think this as a cost factor for diabetes, family history, living place, and you can show that as a visually as a bar diagram here, and pie diagram also sometimes you use living place, rural and urban. And if it is a quantitative variable, you can show the descriptive statistics. Minimum descriptive statistics you have to show is the number of samples, average, standard deviation, skewness, range is the minimum and maximum quartiles and all. So I have shown for cholesterol, and this is an actual study, but I masked the study and just to show the tables. And you can show visually also the outcome. Here only you can see cholesterol is one of the, it's not an outcome. Cholesterol is one of the risk factor, and risk factor visually also you can show the variation in the risk factor, and this is called box plot. Different types of graphs are there to show the variation. I'm not getting deep into that. And you can show the relationship between a risk factor and the disease, actually. Sorry, and the outcome. You can use living place is more of a risk factor here, and abnormality is more of a outcome here. So, is there? I want to see if there is a relationship between the risk factor and outcome. You can show here both are qualitative factors. That's why you are using box plots. It depends upon what is your risk factor, qualitative or quantitative, or what is your outcome, qualitative or quantitative. It's very important actually. You can also show the tables, and here also you can show the tables here actually. Family history and cholesterol, like that. You can use different gaps, and scatter diagram is also, if your both variables are quantitative, you can use scatter diagram here. There is very easily show there's a difference, there's a relationship between waist circumference and body mass. If waist circumference increases, body mass index also. There's a very clear known factor in clinical. So that's all I conclude. If you have any questions,
if time permits, can you just go back and describe some of those special graphs which you had actually skipped now?
Okay, you have time?
Yeah, another 10 minutes we can.
Yeah, we
okay.
can take that.
For graphs, you have to understand the type of variable.
Yeah.
So I'll go back. So there are different types of variables in clinical thing. One is called qualitative variable and quantitative variable. Qualitative variable is more of a category. Actually, sex, blood group, family history, are called qualitative variables. In qualitative variables, there are two different types of scales. One is called nominal scale and ordinal scale. The difference is you can rank the category. So here stages of tumor, disease severity, pain scale, BMI, are all still it is qualitative, it's a category. But I can say stage of tumor, grade 4 is more serious than grade 3, I can say. So I can rank the category. That is called ordinal. And there is also quantitative. I'm not getting, because of time, 3, 4, 5 are called quantitative variable. It can be measurable, like temperature, height, weight, blood pressure, HbA1c, like that. A lot of quantitative variables are also there. So you have to be, once you have the research, so what data you collected, first you have to transform that data into a variable. That is a very crucial step in research. For that, statisticians' help is very much experienced. Statisticians' help is very much required. And also, all the statistical test depends on the type of variable. Statistical test and graphs depends on the type of variable. And there are 4 types of variables: qualitative, quantitative discrete, quantitative continuous, time to event. So sometimes time is also a variable here. For example, in survival analysis, the onset of the disease, how much time it takes for the onset of disease. Or sometimes in cancer research, death of the patient, what is the time taken, survival or not. After 4 years of follow-up, the outcome is whether the patient survived or not survived. That is called how much time, the time from the starting point to till you finish your study. So what is the time for that event to happen? So here that event only you have to define. The event has to be defined by the domain expert, not the statistician. Event may be the onset of disease, event may be survival, or even maybe non-survival also, whatever. You have to define the event. Even sometimes marriage is also an event, Actually, in human general, simple example, marriage is an event. So like that, time to event is also one of the important variable in clinical research. Most of the survival analysis, time to event is a very important variable. And if you have one variable, only qualitative, you can use bar chart and pie chart. If it's a quantitative, you can use histogram, box plot, and dot plot. And if you want to know the relationship between two qualitative variables, if you think one is a risk factor and another is a outcome, if you want to know the relationship between two qualitative variables, for example, living place and whether they are diabetic or not diabetic. So whether they are diabetic or non-diabetic is a qualitative outcome variable. Living place, rural or urban, is also a qualitative. If you consider living place is a risk factor and diabetic or non-diabetic disease, presence or absence of the disease is an outcome. If you want to see the relationship, a covariation pattern, you have to use bar chart. Likewise, if there is a both the variables are quantitative. So I told you obesity, so BMI and cholesterol. If you want to know the relationship, you can use scatter diagram. And one is qualitative and another is quantitative. For example, cholesterol and disease, presence and absence of disease. Cholesterol risk factor is a quantitative variable and presence and absence of the disease is the qualitative variable. There you have to use, still you can use histogram, and here the box plot is the ideal way to use that. I'll show that example. Now you see the examples now. See, here one qualitative variable. Just I want to summarize one qualitative variable. You can use box plot, bar chart here. So here family history of diabetes. For example, in my data, 56% have no family history of diabetics, 43% have. It shows that there is not much variation in the family history. And you can show if there is one variable, you can show either use bar chart or pie chart. Here the living place is the qualitative variable. I use the pie chart to summarize that actually. So 76% have rural, come from rural, and 28%, 23% of come from urban. So in every research, you have to do a descriptive analysis. Definitely, if you have all the variables, you can present visually, either visually or using mean, median like that, the appropriate percentage and mean. That is called baseline analysis actually. So at the minimum, you have what are the population, you have to do some baseline analysis. For baseline analysis, these graphs and tables are very useful. So this is the two quantitative variables I present as a table. This is called baseline analysis. So at the minimum, you have to present average, standard deviation, skewness, range, minimum, maximum, and the quartiles. And if there is one quantitative variable, you can present visually as this is called histogram, and you can superimpose normal curve also to see that whether my sample follows a normal distribution or not. If you see this, approximately it follows a normal distribution. My sample size here is 252. And there are different patterns in histogram. This is called skewed distribution. Left skewed because right skewed, lower values are more, higher values are less. In left skewed distribution, lower values are very less and higher values are more. In normal distribution, both higher and lower values are equally distributed. See here, this is called normal distribution, no skewness. Both here, the mean, median, mode will exactly equal. And this is called right skewed. Right skewed means lower values are high tail is in the right side, because based on the tail only we are saying right skewed, or here the tail is on the left actually. So higher values are more and lower values are. And this is very important graph, very easy to understand. This is called box plot. And here this value is called lower extreme. And it will also throw you the outliers. This dot is the outlier. This is called the lowest minimum value. And this is a quartile 1 or 25th percentile, means that 25% of your sample is below this value and 75% of your sample is above this value. This is called median. 50% is below, it's more like an average. 50% is below, 50% is above. And this is called upper quartile. 75 percentile called 75th percentile or quartile 3, and 25% are above this value and 75% are, and this is called the maximum value. So this will give you the clear picture of your data, variation in your data. And this is called dot plot. This is not widely used now. The box plot is widely used, very easy to understand. So you can use box plot for describing variation in one single variable, quantitative variable. And if there are two variables, you have to show that as a, this is called cross tabulation. If you want to present it, tabulate, aggregate that. So here one variable is abnormality and another variable is the living place. There are two categories in living place, rural and urban. Abnormality, there are three categories: normal, one abnormality, and two abnormality. So here the values are count and percentage. Do you think from looking at this table, do you think there is any relationship between abnormality and living place? But the table, and from this table, can I infer any association between living place or covariation? In statistical, we call covariation. Is there any association between living place and abnormality?
Both one abnormality and two abnormality looks almost alike.
See,
The sample size for rural and urban is.
see, look at the rural. Rural, 38% of two abnormality and 39% are one abnormality, and 21% of the samples are normal people. And in urban, but almost same. See, 38, 41, 39, 43, 21 and almost same. So do you think a living place has got any impact on abnormality? By looking at this table, there is no impact. Do you agree?
Yeah.
By looking at this table, do you agree?
Yeah.
But this is not enough in research. We also statistically have to test whether this association is statistically significant. That is why the statistics comes into place. So you have to present three things in statistics. One is looking as a table, next is a visual part is, and third is the hypothesis testing. So the three statistical tests to prove that the association statistically, the association is statistically significant. So this is the table and this is the graph. So looking at the graph, almost same, right?
Yeah.
Rural and urban, if you look at rural and urban, the abnormalities are almost, the different categories of abnormality are almost same. Yeah. So it is very clearly seen. If you give that graph, it is more easily seen. Do you agree? Than the table.
Yeah.
So here, the both are qualitative variables. You have to use bar chart here. You cannot use pie chart. If you use pie chart, it is very clumsy. So if you want to show the relationship between two qualitative variables, you have to use bar chart. This is called clustered bar chart. Statistically, it is called clustered bar chart. And if you want to take the one quantitative variable and one qualitative variable, I am taking now. So the qualitative variable is cholesterol and the quantitative variable is the living place. So do you think there is any association between living place and cholesterol by looking at the table? How you see? How you
Again,
conclude on that?
doesn't look like having any.
See, if you look at the mean, almost same, right? Rural also, the average cholesterol is 147,
Yeah.
and urban also, the average standard deviation is nothing but a variation measure. So standard deviation is almost same. By look at the table, we see that rural and urban are almost same. That also means there is no relationship between the living place and cholesterol here from my data.
Yeah.
See, if you picture as an histogram, I show if there are one qualitative variable and one quantitative, you can show as a histogram. Look at the histogram, almost same, right?
Yeah.
Percentages are almost same.
Yeah.
This is a range actually. 75 to 100, 100 to 125, 125 to, so you can have some ranges, and in that range, how many people are there? So for example, you take 75 to 100 cholesterol, 2.82 samples are 75 to 100 in this is another variable, family history of diabetes. So here family history of diabetics has got no impact on the cholesterol actually. So 2.82%, 1.8. On the all ranges, the percentages are almost same, not wide difference. So is to use box plot, this is more visible. So now use the box plot. Same living place and cholesterol. That I showed as a table. Now I showed as a box plot. So what do you infer from this box plot? See, there are some outliers in the rural. So the rural, so what you have to do, you go back to that outlier value and check that whether it is really correct. Maybe due to some error or wrong measurement also it may happen. So here only statistician will not decide on that. Only the domain expert, and go back to the data and see that where the data comes from and whether it is really correct, because it will impact your statistical test. That it will change your statistical conclusion. So you have to be very careful on the outlier, and box plot will give you the outliers visually and go to that value approximately here 249 or something. Statistically it says an outlier, but it doesn't mean it is an outlier. You have to go back and see that whether it's really an abnormal value. Only the clinical person has to say really it is an abnormal value or outlier. Whether I have to include in the analysis or not, you have to decide. Statistician will not decide. So if you look at that, averages are almost same. Variation is also almost same. There's only the difference is in the minimum value. Maximum values are almost same. So the impact from the visual, we can see there is no impact of living place on the cholesterol, but it has to be statistically also. Third thing is you have to test statistically. So that is the third thing you have to do. I have not shown this. So you have to use here, you have to use a student in statistics, we call student t-test. T-test for independent samples. You have to do the test whether there is a difference between rural and urban. You have to test it and conclude that. So all the evidence you have to say that you have to, based on that, you have to take a conclusion or take a decision. And this dot plot is not widely used. Here the qualitative variable is abnormality and waist circumference. Here you see a pattern. What pattern you are seeing here?
Increasing.
Is that definitely the waist circumference, the abnormality, waist circumference has got an impact on the abnormality. So for example, if the abnormality is increasing, waist circumference, average waist circumference also increases. So there is a difference in the average waist circumference between the three abnormality groups. So visually it is very clear. And you have to, and variation is also, one has got high variation, very lesser variation in normal people. So this has to be statistically tested whether there is the waist difference, waist circumference differs among three groups. That is all. here the statistical test is called one-way ANOVA. Likewise, you have to identify the appropriate statistical test and test. And this is called Pearson correlation. So Pearson correlation, I told you, you have to use a scatter. Both are quantitative variables. You have to use a scatter plot. So here, the relationship between waist circumference and body mass index, and you have to use a scatter plot. After that, you see there is a relation. If the waist circumferences increases, body mass index also increases, and this has to be statistically tested using, here I have put that statistical test using correlation, Pearson correlation. So the Pearson correlation between body mass index and waist circumference is 0.80, very high correlation. That is also very clear in the graph chart. Okay. Any other questions?
I think this is the end of the slides. No? I think this is the end of the slides. Anyway, I think statistics is not a simple subject that can be assimilated in a single go. It takes several, probably, sessions, short
No,
sessions.
very. I give very high level, some 35,000 feet high level view only. That it has to be thought progressively. You have to learn.
Yeah. It takes time.
Suresh, I just wanted to know. Hello.
Yes.
Tell me.
I just wanted to know. We have HbA1c, for example. So it can be used as a quantitative variable and qualitative variable.
Pardon?
Like
Which variable?
HbA1c.
Yes, actually, there are in clinical research there are a lot of quantitative variables. Based on some norms, they convert into an ordinal qualitative variable, right? BMI, obesity. Obesity is nothing but, BMI is nothing but obesity. So from the BMI is a quantitative variable. They convert the quantitative variable into a lot of categories. Obese. What are the 4 categories in obesity?
Mm-hmm. So
And
we can
convert the quantitative variable into a qualitative variable for the clinical. For the why they are converting, I don't know. For clinical, easy interpretation of clinical or whatever. But from the statistical point of view, quantitative variable is the best to know the variation.
Yes, but likewise, probably HbA1c can be used to make it as a qualitative variable by way of putting it as a normal group, like a poorly controlled, well controlled, like that.
No, that is why.
So we can use both in the same paper.
If you convert that into for clinical interpretation, for clinical interpretation, that is convenient. From statistical analysis point of view, that is not. You have to keep it as a quantitative.
And I think that Suresh said we should have more sessions. 1 session per month.
Exactly. That's what I was telling. We have to have more sessions because on specific areas.
Try to enlighten on key points in biostatistics.
Yeah.
1 hour is not enough. And it's a very
high level view because
for a practicing physician.
See, this biostatistics, I am conducting a 42 hours course. I am running a 42 hours course for the in one of the management institute, they have a executive diploma in healthcare management, and most of the people are from clinical people, doctors and all. And
online also typically there.
Face to face and online combined actually. And 42 hours of the course I'm running, a lot of exercises, and you have to do a lot of assignments, exercises, and project and all.
What is the time of the classes actually?
You can You can check with Laila instead of Viva, Chennai, and usually they will conduct in the weekend actually, Saturday, Sunday.
How many days actually it is? How many hours it may go?
No, I only decided that course 42 hours actually.
No, total, but how many days you finish that?
How many days?
Yeah.
No, it will run for 6 months actually.
Oh, 42 hours in 6 months.
42 hours in 6 months. And now they made it as not offline. That is why not more people are enrolling.
Do you conduct SPSS workshop also?
I am conducting SPSS workshops also.
For postgraduates, so that will be how to use SPSS.
Are you conduct it online or offline? Are you conducting it online or offline?
See, anyway, my experience online will not be very effective.
Okay.
Because even offline, I can travel one day and leave a gap.
Yeah.
And next month I can come like that. In between, we can have some exercises on online. Actually, because I am doing a course in data analytics with Python is one language actually. That is for a management MBA.
Yeah.
That is it's a combination of hybrid course, combination of online and offline. So every month I will travel for 1 or 2 days there, do an offline course, and in between I have a lot of assignments and all. That I will do with the offline, online Zoom meeting or WhatsApp like that.
So actually, if anybody is interested in the sort of course, they can contact us.
I will give my number. You note out my number.
Yeah.
My number is 98. First slide it is there.
Yeah, we have it. Actually, those who want that actually can contact us so that we can.
If anybody wants, you can contact me. I can do the course actually.
Yeah.
So I run it in SCMS Cochin, 2 days course only. SPSS workshop only for faculty development program.
Yeah.
I did it for 3 days SPSS course actually.
Yeah.
With the real case studies and all.
Those who have joined today is all are really interested in the research or statistics. Otherwise, it's a right topic for the practicing, but it's a very essential item for the postgraduates and people.
You can also take as a visiting faculty for any course in the college or something. If you want that, I can take up that course as a visiting faculty.
Right. No, for medicine department, probably you can arrange that for PG students.
Usually in community medicine,
Yeah.
lot of
For all departments, because they have thesis and all, they need this SPSS and all this statistics. Any comments or can we find out now 1
5 4 7 6.
Taking now questions from the participants because that's a gray area for most of the thing.
Yeah. No, it was actually an excellent session for beginning as a beginning.
Okay.
Statistics was very good because we understood the intricacy of statistics and the importance of statistics in medical research and clinical research. It is not only for doing research, also for understanding the research article. You need to know statistics. Yeah.
As I told you, it's a collaborative approach.
Yeah, exactly. Not only for those researchers, but also for those who follow the research or read the article.
For reviewers, also reviewers.
Yeah. No,
I'm
for
also doing
example,
some
yeah,
review, journal
today and
reviews.
yesterday we were actually, we were analyzing one of the stats of my study, that is
Yes,
the
yes, yes.
ROC, area under the curve, all those things. Like, there are a lot of complicated things. Actually, he made it simple. Actually, how to understand those things. What is specificity? What is sensitivity? What is positive predictive value? What is negative predictive value? These are important things. What is area under the curve for a particular variable? All these things are made simple by his experience. He can tell us in simple terms. It's very important. So I think probably we can have more short sessions like this once in a while, and to refresh.
Also physical meeting or workshop.
Yeah,
Okay.
maybe
Like,
we can also
especially
plan
for
a
the
workshop on
first
this. Yeah, Rojit, if you can take up a workshop on statistics,
Yeah,
I can take it.
use of his service, and we can do that.
sure, sir.
Yeah,
I
please.
can travel, not a problem. From Chennai, I travel.
Right.
Yeah, we will discuss and let you know, sir.
Yeah.
Okay, no issue, no issue.
Okay, thank you.
Thank
Thanks a
you
lot.
so much, sir.
Yeah, it is
This
an
was
excellent.
for your time.